the solar system. Everything in the solar system is held together by the gravity of the sun. We've learned so much more about our solar system through space travel and exploration, as well as using scientific instruments. The sun is composed of hydrogen gas, mostly, about 70% of the mass of the sun, and helium, about the other 28%. 2% are just some other elements that are considered trace because they are so small in comparison to the amount of hydrogen and helium. The diameter of the sun is 1.4 million kilometers. This is approximately 110 times the diameter of Earth itself. So the sun is massive. A nuclear fusion reaction takes place in the sun because the sun's gravity is so strong, it is able to compress hydrogen gas. So two molecules of hydrogen come together with such great pressure and force because of the gravity of the sun, and it makes the helium. That's how we got 30% helium. It also produces massive amounts of energy. This energy released causes the sun to be really, really hot, about 15 million degrees Celsius, and that's what causes it to glow. About 600 tons of hydrogen are converted to helium every second. So this reaction is happening on a massive scale. The surface of the sun is constantly moving. So remember, we decided that we were moving around the sun because the sunspots were moving. So solar prominences are streams of glowing gas that arch into space and can last for minutes or days. So on the surface of the sun here, we see a solar prominence, and it's this escaping of hot gas. And it is giant. This is the size of the Earth in comparison to this solar prominence. A sunspot is a region that is cooler, and they look darker than their surroundings. A solar flare happens near a sunspot when a violent outburst of energy is produced. These send high energy particles into space and can affect satellites and other technology. So solar flares happen near a sunspot. They send out energy into the atmosphere, the space, not atmosphere. And those are often on the spectrum of electromagnetic radiation. And that's how they can affect satellites and other technology, is the waves that they give off. Solar wind is a high energy particle stream from this solar flare that can be felt throughout the solar system. So solar flares cause solar wind, and anything in our solar system can experience this solar wind. If it doesn't experience the solar wind, it is no longer within our solar system. The magnetic field of the Earth's atmosphere actually protects us from this solar wind. So it keeps these particles from entering, or these waves and particles from entering Earth's atmosphere and affecting things here on Earth. The moon. In 1968, July 17th, Neil Armstrong and Buzz Aldrin, also known as Edwin Aldrin, landed on the moon. Only 59% of the moon's surface is actually visible from Earth. So from Earth, we always see the same side of the moon because it rotates at the same time it takes to go around the Earth. So its rotation only allows us to see 59% of it. There's a great video on this explaining why we only see one side of the moon on our course website. So the phases of the moon are something that's often questioned. Why do we have phases of the moon? It's a common misconception, and it's not something we covered in this class, but I thought I'd include the link in our course website if you wanted to take a look. The planets. we can divide the 8 planets of our solar system into 2 main categories. There's the inner planets, Mercury, Venus, Earth, and Mars. They're rocky, sometimes called terrestrial planets, and they're smaller and closer to the sun. The outer planets, so Jupiter, Saturn, Uranus, and Neptune, these are called the gas giants. Most of these have lots of moons. So for instance, Jupiter has 69 known moons, 4 of which would be large enough to qualify as planets. These 2 subsets of planets in our solar system are separated by an asteroid belt. Note that our textbook describes Pluto as a planet, but it is not classified as a planet anymore since 2006. It is a dwarf planet. Take a look here and you can see the inner planets closest to the sun. There's an asteroid belt, and our outer planets. Again, Pluto is not included. For more information on each of the 8 planets, which you'll need to complete your learning guide, take a look at your textbook from page 412 to 415. I wasn't going to type that all out. It was great information, good pictures. So I'll just let you guys take a look there. Other bodies of matter. So other things in our solar system include comets and asteroids. So comets are basically snowballs of frozen gases, rock, and dust that orbit the sun. When they become heated, they glow, and the dust and gases form a tail that we can see streaming through our night sky. Asteroids are smaller bodies of rock or metal that orbit the sun all the way out to Jupiter. Smaller bodies of rock, meaning that they aren't on the size of a planet. A meteoroid is an object in space that ranges in size from dust to small asteroids. You can think of them as space rocks. So a meteoroid is something that's still in space. A meteor is the fireball or shooting star that forms when a high-speed meteoroid enters Earth's atmosphere. So a meteor is a meteoroid moving through our atmosphere. Or potentially another planet's atmosphere. Doesn't it just have to be entering Earth? A meteorite is a meteoroid that has survived the trip through the atmosphere and actually hits the ground here on Earth. There's a great little video here if you want to take a look for asteroids. And just a little look at the whole universe. So Earth is within our solar system. Our solar system is within the Milky Way galaxy. The Milky Way galaxy is within the local group, which is within a local supercluster, which makes up part of the universe. So we are a very small speck of rock within the universe itself. Voyager 1 and 2 were really important discoveries for NASA. So NASA couldn't send a heavy spacecraft to view outer planets, so they designed Voyager 1 and 2. They were launched really close together in time, so but their trajectories were different. This is because they use gravitational assist from the planets. So Voyager 1 used gravitational assist from a bunch of different planets. So we can see here it went to Jupiter, to Saturn, and then left the solar system, whereas Voyager 2 went to Jupiter, to Saturn, to Uranus, to Neptune, and then launched out from our solar system from there. They travel at 16 or 17 kilometers per second, just using the gravitational assist of other planets. They don't really propel themselves. They collected and transmit data and images from their journeys back to Earth. They're no longer collecting images because they've been out there since the 70s to preserve battery. So the last images they took were in the 90s when they were leaving the solar system. There's a really big lag time between data transmissions the further it travels from Earth. And they are actually still moving and still collecting data. Some of their instruments have been turned off, but they are still collecting some data and sending it back to Earth so we know what space looks like beyond our solar system. It was really cool to look this up. I did include the Voyager link below so you can see where they are now and what they are up to. Some really important discoveries came out of Voyager. NASA says it's probably the most scientifically productive mission ever. It was only the second mission to visit Jupiter and Saturn, and the only one to ever visit Uranus and Neptune. They provided the first detailed profiles of the atmospheres of the planets that they used gravitational assist for. So for Saturn, Uranus, and Neptune, and improved the understanding of the characteristics of the atmosphere of Jupiter. They revealed enormous amount of detail in the rings of Saturn and discovered the rings of Jupiter, and then provided the first detailed images of the rings of Uranus and Neptune. They took pictures of Earth's moon and discovered 23 new moons in the outer planets. They made significant improvements in the measurements of the magnetospheres at Jupiter and Saturn, so the magnetic tendencies of these planets, and provided the first measurements of the magnetospheres of Uranus and Neptune. The significance of the Voyager is vast amount of new knowledge about our outer solar system, and it's provided so much more interest. So that interest has led to more missions to Jupiter, to Saturn, and satellites looking outwards. The discovery of an active volcano on a satellite of Jupiter was probably the greatest surprise. It was the first time that active volcanoes had been seen on another body in the solar system. And it appears that this affects the entire Jovian, so moon system of Jupiter. Don't forget to take a look at the learning guide for this, and there's some extra practice in your textbook if you are looking for it.